Hello, everyone. Welcome to Math 3C, which is Calculus 3. I'm your instructor. My name is Tarek Hossain. We are going to talk about a few things today. This is the first day of classes. First, I'm going to talk about the syllabus, go over the basics of the syllabus, just an overview so that you know what are the expectations for the class. And then we are going to talk about the materials that we are going to cover, and then we'll get started right away without much delay. All right, let's see. Okay, I see a message that someone did not receive the syllabus. Please send me an email. I'll send it to you. The syllabus was sent on Monday. Okay, so if you have not received it, please do send me an email. I'll go ahead and send it to you. It's probably because you have added the class after Monday, maybe. That's a possibility. That may be the reason. All right, so for the syllabus, a few things. To get started with the class, by the way, you need to go to math.suflek, SUFLEK.com. You need to go there, create a free account, and then sign up for the class. There are a few other classes. You want to select Calculus 3. Okay. By the way, this is how the screen looks like. So if you go there, math.suflek.com, this is what it's going to look like. And then you may want to just click on this and create an account for yourself. And then from there, you will go and sign up for the course. I'm hoping that everyone has already done it. If you have not done it, please go to the site math.suflek.com and sign up there. Now, I'm going to show you something. I'm going to log in there with my user ID. Okay, Calculus 3, select. And this is where your homework is. So all the assignments for the semester will be here. And you are expected to participate in the class through Zoom every Wednesday from 6 o'clock to 8:10 p.m. All right, 6 p.m. to 8:10 p.m. And then I will be recording the classes, and I will send it to you only if you miss the class. Typically, I don't send the recording because many students think that, oh, okay, I'm going to watch the recording. The objective of the class is to actively participate in the class through Zoom, not just passively watching the video. And the reality is that if I send the recording, many times students don't even watch it. So I would encourage you to participate in the class, and participation is 10% of your grade, just to remind you. Participation is 10% of your grade. And participation does not mean that you just join the Zoom. Participation means that you join the Zoom and you actively participate by asking questions and interacting with me as well as with other students. So please make sure that you are not only joining Zoom, but participating in the class. That's very important. Now, you'll do the homework here. Typically, if you run into any problem, there is an email link. So someone is asking about the textbook. Please wait. I'll get to that. It's coming up. Okay. And also another student needs the add code. Please note that we do not provide add codes anymore. If you are in the waiting list, or if you were in the waiting list, I already have sent you an authorization to add the class. So if anybody was on the waiting list, you already should be receiving authorization to add the class. So that means you log into PAWS and you should be able to add the class. It is math for mathematics 3C, and the section number is 1147, I believe. Yeah. The section is 1147. So that's how it works. Now, if you're a student who is not in the who was not in the waiting list but would like to add the class, please send me an email. Okay, here is my email address: mhossain @hartnell.edu. Okay, please send me an email at mhossain@hartnell.edu and let me know that you are interested in joining the class. I'll be happy to authorize you and you can join. By the way, when you email me, please provide your Hartnell student ID. I will need your Hartnell student ID. So please provide that. Any question?
I have a question, teacher.
Yes, please.
So we need to buy the course, or we're gonna add it from the school? How is it gonna work?
So buy the course means like when you're taking an online class or any class, you are buying the textbook or online access, right? So
Yeah.
that's pretty much what it is. You have to buy the access. However, I told people, if anyone is going through financial difficulties, please personally send me an email. I will send them a request for discount. Okay, so if you feel that you need financial assistance, please, by all means, let me know. I'll let them know. Maybe they'll give you some discount. And also keep in mind, your financial challenges should not stop you from taking classes. Keep that in mind, okay? So the vendor I'm working with, they're probably the most generous, okay, of all of the vendors that you use.
Okay.
How can we go about using our book vouchers? Because we have one voucher left over to pay for it, but I can't use it.
Yeah, let's talk to me offline, okay? Shoot me an email. I'll send you the instructions, or talk to me after the class, okay? About individual scenarios. But in general, if you're having financial difficulty, please let me know.
Okay.
Any other questions? Okay. All right. So student ID and email. Those are the things I need from you if you want to add the class. Then office hours, very important. My office hours are Tuesday and Wednesday from 8 o'clock to 9:15 p.m. 8 p.m. to 9:15 p.m. Sorry, 8 p.m. to 9:15 p.m. Tuesday and Wednesday. So for Wednesday, it will be right after your class. So for tonight, it will be right after the class. We are going to have an office hour. And if you don't understand anything in the class, you of course are welcome to ask me questions in the class, and I will explain it to you. However, if even after explanation in the class is not quite clear, I would strongly recommend stick around after class I will go over the topics one-on-one with you and make sure that you understand it. So please take advantage of this thing. That is the reason I kept the office hour right after the class, so that you can just hang around and ask me questions about things that you didn't understand. These things are still fresh in your mind after class, right? So you can go ahead and clarify your questions. So join the office hours Tuesday and Wednesday, 8 to 9:15 p.m. And the Zoom link is the same Zoom link. Okay, exact same Zoom link. Now, for this class, okay, hold on 1 second. Some question or comment in the chat. There was a question / comment on the chat. Do we communicate on Canvas? By the way, I do not use Canvas for this course. So all the communications have to take place through Hartnell Gmail. All of you have Hartnell Gmail, and I may consider some other resources online, but I haven't thought about it in details yet. But for now, Hartnell Gmail, that's how we communicate. So please don't send me email message on the Canvas, because I don't check my Canvas emails regularly. And also, even if you are sending me email on Canvas, I probably reply to your Hartnell Gmail. If I know your name, I have your email address. And has anyone in this class used Discord?
Yes.
I have.
Yes.
Yes, I do.
I have been thinking about it. Okay. What is your experience like using Discord?
It's good.
Pretty good.
Yeah, it's pretty good.
easy.
Okay. All right. Pretty good. I see. How do you compare Canvas with Discord in terms of communication?
It's a lot easier.
It's way better.
Yeah.
Discord is much better.
Yeah, we can just have a group chat for the
Yeah.
class.
Yeah, so I might consider opening up a Discord. I have an account, opening up a server for this class. Okay, Discord server, and then maybe I'll try it out. But give me a couple of weeks. After that, I'll think about it. Okay, let's get started first, and then I'll probably create an account, create a course shell there, and then, or server. I think they call it server, and we will communicate over there. And that's also a good place to communicate with each other, right? With the students in the class compared to Canvas. I have a feeling. Is this right?
Yeah, it's
Yes.
basically like an open chat.
It's like an open chat. Okay.
Yes.
Wonderful. And you can, of course, send private messages too. So let's say you're John, you want to send message to Jason, or Jennifer wants to send message to Jessica. You could still do that, private messages.
Yes.
Okay, cool. That sounds like a thing that I might consider. By the way, I am very pro technology. You'll realize it as the semester goes by. I encourage communication among students, between students and myself through technology. I started a WhatsApp group last time, but I didn't get as much response. Here and there were some communications, but not active communications. I didn't see that. So maybe I'll try Discord and see what kind of response I get. All right, so office hours, we talked about it. Homework, we talked about it. Hold on 1 second. if we want to know our grade, okay, let's see. Do we email you as well? Yeah, grade is how to calculate your grade. I'm going to talk about it. That's one of the discussions coming up. Okay, so please be patient for a minute. So homework is here. Typically, for other classes, what I do, I actually upload my videos to this server, and then I have step-by-step examples. So I will probably start adding the step-by-step example for these questions. I may already have it for some of them. So, oh yeah, I already have them. I forgot. So for instance, you're working on this problem, right? And you don't know how to do the problem. You can look at it. You can click on this step-by-step example. It will give you an example that is similar to the given problem. So you're trying to do something here with this vector, and here is an example, extremely similar, pretty much literally the same problem with different numbers. And then I also had a video link here where I go over a similar problem, but I haven't uploaded those videos, or actually I haven't created those videos because I record the lecture, so you already have access to the video. So you have multiple resources for help. Of course, the lecture is the first thing, lecture videos, and then you have a step-by-step example here, and then office hours. Then if you're stuck with the problem while you're working, you can email me. So do you see this email link here? Email link.
Yeah.
Okay. So you can click on that, it'll open something. You do not have to tell me which problem are you working on. Please don't tell me that, oh, I'm working on this and that problem. Just write down here what your problem is. Okay, I'm having difficulties trying to do this. That's it. Because the system is smart enough to automatically send me the problem that you're working on. So I know which problem you're working on. So please just write down what is the issue that you're having right here in this box and send it to me. And please do not send me email. I see that sometimes at the beginning of the semester, mostly, students send me an email while they're working on the problems. Let's say you're working on this problem, but you go to your Gmail and send me an email saying that, oh, I need help with this problem. Please don't do that. Just use this email link that comes to me directly. And also, there is another feature in this portal. You can actually take a picture of the problem that you're working on. Let's say you're working on a problem and you need some help. So you can just take a picture of the problem and send it to me. And make sure that your picture is in the JPEG format. Otherwise, sometimes I have difficulties opening the image. So make sure that it is converted into JPEG. Sometimes I have noticed that for some of the phones, if you just take the picture and upload it, I get to see it. But sometimes, because of the formatting issues, I do not see the image. But anyway, you are able to take an image or take a picture of the paper that you're working on and send it to me. I'll get it and I can look at it exactly and see where you are making mistake. Therefore, I could help you. And believe it or not, there is also an option for texting. Okay, so if you're working on a problem, you can text me, but please don't do it. They charge me money for that. Okay, so I may end up becoming poor. But it's not too much. I think it's 5 cents or 10 cents per text, something in that range. But then if a lot of people start sending me text messages from here, okay, it directly comes to my cell phone number. So if you really need any urgent help and you need to send me a text, don't send it from here, but rather send it from your cell phone, and that way I don't get charged. But if you send it to the website, they will charge me for every single text. Okay, so you have all the tools that you need to be successful in this class and be able to understand the topics and be ready. Now it is your job to make sure that you use these tools that are at your disposal and enhance your learning experience, and you do well in the class. So as far as homework is concerned, this is what I expect you to do. Any question on the homework end of things?
I had one.
Yes, please.
So if you type in your answer and it ends up being wrong, do you get like multiple chances to get it right? Or
Yeah, a good question. I kind of don't want to tell you that answer. I mean, respond to that question, because the way I set it up, you can try as many times as you want. It don't penalize you. Okay. So literally infinitely many tries. So if you put something in the text box and click submit, check answer, it will tell you whether your answer is correct or not. And you can try as many times as you want. I don't restrict it to 2 or 3 times.
okay. So
Anything?
not just
Yeah.
till you click submit assignment, that's when it's done.
Oh, by the way, that's another thing, another point. Submit assignment. If you, let's say you are working on a problem and you just submitted the assignment, but the assignment is due, let's say tomorrow, but you submitted it. Now you want to go back and work on it again because you didn't get 100%, but you'd like to work on the problems more. You can do so even after you submit it. And the system is designed in such a way so that doesn't matter how many times you submit it, it will take your highest score. Only time you cannot work is if the deadline has passed. Okay. Even if the deadline has passed and you forgot to hit the submit button, that's okay too. It will record everything. Every time you click on this check answer, it actually records your answer. So nothing to worry. Any question on this topic, anyone?
No.
Professor,
Yes.
will the exam format be like your Calculus 2 class?
Yes.
Okay.
Any other questions, anybody? David, are you here? David, I don't see you. David. Okay.
I have a question.
Yeah.
So when you say we have to participate, like, can you give me an example of what participation in this class is?
You're doing it already. Talk to me in the class. That's participation.
Okay, cool. Thanks.
Yeah. Participation doesn't mean that you join the Zoom meeting and you mute yourself on the other side and you are watching TikTok. That's not participation. Participation means actually engaging in the class, asking me questions. If anything is not clear, clarifying it, responding to other students' questions, like as you would do in a face-to-face class. So that's what participation means.
Would typing in the chat count, or does it have to be?
Yeah, no, typing in the chat also counts, of course. That's a form of communication. Some people are shy on the Zoom, on the microphone. They don't want to talk. I understand. Or maybe you may have some background noise, or there is a baby crying in the background, whatnot. You can type in. That's okay. But I prefer that when it's class time, you be in a room where it's quiet and it's just you and the computer or laptop that you're joining through, and ask me questions by unmuting yourself. That's my preference. But if for some reason you need to type in, please do so by all means. It's better than not doing anything. Okay. Someone says, I'm not familiar with your Calc 2 class. Can you explain the exam format? So the exam format is going to be like this. All right. In the exam format, what you will not see, you will not see this step-by-step example. Okay. Or you will not see this live help. Or you will not probably see the email. So exam format is going to be like homework, but in a regular homework, you have an example problem, right? Sometimes you have a video. In the exam, you will not have those. Otherwise, it looks like you're doing the homework and kind of like replicating the similar problems. There is a question, the exams, hold on, somebody said something. Oh, open book, open notes. Okay. Do we get unlimited tries on the exam? Yes, I actually give you unlimited tries on the exam too. But the catch is that exam problems are not going to be multiple choice. I don't give many multiple choice questions. It's going to be mostly fill in the text box. So you actually have to do the work and turn in the final answer.
So exams are on the same website as well?
Yeah.
Oh.
How long do we usually have? So let's see. How long do we usually have to finish the exam? Will our work on the exam be saved so we could go back to it and finish? Yes, the work on the exam will be saved and you can go back to it and work on it. My objective is to ensure that you learn the materials. I'm not a policeman, okay? Policing you is not my primary objective. My primary objective is to teach you, and I expect certain level of integrity and honesty. You are taking these exams on the other side. I don't see it, right? How do I know that your uncle who has a PhD in math not doing your homework? I don't know. I expect certain level of integrity. So exams are open book, open notes. However, you cannot be communicating with any other human being. You can even Google things. You can search on the internet and do research and come up with a solution to a problem. What you cannot do, you cannot ask anybody else, directly or indirectly, any other human being for help, except for me. You can ask me, by the way. If you're taking an exam and you need a little help, you can actually send me an email from the system.
So the exams will be during our regular scheduled class time?
Most likely, no.
Oh, no?
No.
Okay.
Exams will not be during the regular class time. The reason is that I actually try to give you a break, and during the class time, I kind of want to cover as much as possible. I like virtual classes, and there are some benefits of it. One of the benefits is that I give you exams which are kind of like take-home exams. However, I use that class time for lecture.
So they'll be available for like a certain amount of days or just one day?
I normally give for the midterms, I give like somewhere between 6 hours to almost 18 hours, okay?
Okay, so it's just one.
Yeah, it's literally one day, but time is not a concern for you. You don't have to worry about time. You will have plenty of time to work on it.
So they're not like timed, like it ends at a certain time. It's just like a certain, like certain.
It ends at a certain time. You're right.
But it's
okay?
not like a timer counting down.
Yeah, it's not like I'm gonna give you 50 minutes to work on this midterm. If you went over 50 minutes, you can do anything. No, I'm not that strict. What I do typically, I'll give you maybe 6 hours to work on it, or I'll open it typically what I do, I open it at 6 o'clock in the morning and close it at midnight.
Okay.
Okay, so literally you have the whole day to work on it.
Thank you.
And you're welcome. Now, if you start at, I opened it at 6 o'clock in the morning and you you started working at 10 o'clock and then, oh my God, can I get a little extra time? Then I'll have little sympathy for you. You have the whole day to work on it and you start at 10 o'clock and then now it's close to midnight, you are not done, then I'll not be happy about it. Okay. So please don't do that. Okay, will our work on the exam be safe? Another point I want to make on the exam is this. If you read the syllabus carefully, I mentioned it there, I reserve the right to ask questions about the exam to anybody in the class or everybody. So let's say you take an exam and let's say Alex took an exam and then I can call up Alex, I'll have your number. I'll call Alex up and ask Alex, so, okay, I see that you got 90% on the midterm one. Let me ask you this question. Show me your work and explain it to me. Okay, so you have to be able to explain what you did. Let's say you get 90% in the midterm, but when I ask you questions, looks like you don't even know the basics, then you'll embarrass yourself and you'll put me in an awkward situation where I will lower your score. So please make sure that you save all your work when you're taking the midterm. And I know some of the problems you can just do it very easily. Those are the ones I'm not too worried, but the ones that require work to be able to get to the final answer and you suddenly have the final answer right, but you have no work and you don't know how to explain the problem to me, then we run into an issue. So please avoid that situation. Does it take off points every time we answer it wrong? No, it does not take off points if you answer it wrong. Like if we put the answer wrong the first time, but get it right the second time, will it get points off? No, it will not. Alex, are you clear on that? Okay, thank you, Alex. Are your office hours at Hartnell or online? My office hours are through Zoom. Okay, and they are from 8 p.m. to 9:15 p.m. Tuesday and Wednesday. Is the same Zoom meeting ID and password, and you can connect through Zoom during the office hours. I made the office hours kind of late so that sometimes people have work, you come back from work and you have dinner, and maybe in some cases you even have children to put to bed. So get everything done, be done with the day. Now you can join the office hours and ask me questions and take your time and whatnot.
Another question, teacher.
Yes.
So when it's a new homework in the page, you're gonna send us an email or something, or we only need to check the page?
If you check the page, you'll see see the new assignment, and also I'll be sending you an email as a reminder that, oh, I have put new assignments.
Okay, sounds good. Thank you.
Mm-hmm. Okay, Hector, when will you call us up? During Zoom? What do you mean?
I think he means for the exam questions.
Oh, no, I don't do it on the Zoom. I do it privately. I don't put you on the spotlight. No worries. Remember, I said I reserve the right. Okay, I reserve the right. Doesn't necessarily mean that I will do it all the time. If what makes me concerned, somebody not participating in the class, not participating in the Zoom meeting, and not doing so well in the homework suddenly gets high score on the midterms, that's when I start to worry. If you are participating in the class, you're doing the homework regularly, and I know that you're asking questions and you're clarifying things, you're interactive in the class, and you do well on the midterms, I'm okay with it. I'm probably not even gonna bother you. Typically, I don't call people typically, but when I think I had one conversation with one student last semester or the semester before, who was underperforming in everything but got very good score in the midterm. So that's when I had a conversation. So typically, if you're joining the class and doing everything, you don't need to worry about it. But if you're less than honest, then you may have to worry about it. I want you to be engaging in the class and asking me questions. It's much better to ask questions and do your best and get a C in the class, as opposed to being dishonest and getting an A. Trust me, you're deceiving yourself. And you are adult, you're grown up, you're at college. I expect integrity and honesty and good values from you. Nothing less than that. All right, did I answer everyone's questions? Will the exams be during the weekday or the weekends? I don't know. I have no problem giving you on the weekends if you want. It's okay with me. Would you prefer during the weekend? Anybody?
Well, how long are the tests open for?
Yeah, how many?
Normally, at least 6 hours, I would say, but it will be more likely it will be from 6 in the morning to until like midnight. I keep it open.
I'm okay with the weekends.
Yeah, I'm okay with the
Yeah.
weekends too.
Whatever works for me.
One person prefers not the weekend. Okay. Weekends probably. Pretty much everybody wants weekend except one person. Let's see, who is that person? Let me talk to him or her. Okay. Corey, you'd prefer not the weekends, right? But would weekend make it more difficult for you?
Yeah, I'm usually busy during the weekends.
Okay, no worries. I can make it during the weekdays for you, and weekends for others. That's not a problem. Accommodation should not be a problem. I am happy to provide you with all the things that you need. However, I expect honesty and integrity. That's what my expectation. Okay, I think that's pretty much it for the assignments. Now let me talk about grading. Are the homework assignment once a week? Typically once a week. Yes, Kevin. It's typically once a week. I normally make the homeworks due on a Sunday, but that doesn't mean that I will always make it due on a Sunday. Okay, but most of the times it will be due Sunday midnight. Like the first assignment you see is due on Sunday midnight. Okay, now someone asked me about grades. How do you calculate your grades? Rule of thumb, if you have been doing the homework and you did decent on midterms, that's pretty much your grade. So let's say you've been doing the homework and let's say you got a B in the midterm. That means that you'll get at least a B in the class. Okay, midterm and the final, of course. Typically, homeworks tend to help. One thing I try to do to the students is this. There are a couple of places I try to help you towards the end of the semester. One is homework. So what I do, let's say somebody got 76% on the homework, I try to bump it up to 80%, but I never do it the other way around, never. Okay, it's not going to be 75%. I look at the student, I'm like, okay, this student participated in the class, have been active. Now he's getting 68%, right? How can I make it 70%? So homework is one place I try to help you out, and even more so than that, your participation. If you're at 68%, which is a D, but if you get 70%, you will get a C and pass the class. I look at you, oh, okay, did this student participate in the class? Do I recall the name and those things? By the way, at that time, I kind of manipulate things in a way to help you out. Okay, to help you out. So let's say your participation should be 70%, okay, but I'll try to push it up to maybe 80 or even 90%, okay, so that I can help you pass the class. My objective is to help you, not to hold you back. So please keep that in mind always. So if you're honestly making an effort, you should not have to worry about passing the class. As a matter of fact, I would like to see that everybody gets with a very good grade in the class, like A or no less than B. Now, how do you calculate your grades? We use something called weighted mean. Weighted mean. What is a weighted mean? I'll give you a simple example. Homework, midterm 1, let's say there is one midterm, and final in a simple case. All of them are out of 100. So let's say in the homework, let's say homework is 20% of your grade. Midterm is 30% of your grade for simplicity. This is not the exact number, by the way. This is an example. The exact weights for each category is given in the syllabus. And final is 50%. So these are the weights. These are the percentages assigned to each of these categories. Let's say in the homework, you got 100. In midterm 1, you got 80. And final exam, you got 70. What is your grade gonna be for the class? So these are called W sub i's, these are called X sub i's, and weighted mean is defined as summation I is equal to 1 to n W sub I X sub I. You may have seen it or you may not have seen it. In either case, don't worry. You'll be fine. I'll give you the example, you'll understand it. This may look a bit mathematical and kind of unfamiliar. Don't worry about it. What I mean is this, very simple. You take 20% and multiply it by 100. What do you get? If you take 20% and multiply by 100, what number do you get?
0.2.
20, right? 0.2 times 100 is 20. If you take 30% and multiply it by 80, what do you get? 24. Why 24? Because 0.3 is 30% times 80 is 24. Exactly. Similarly, if you take 50% and multiply it by 70, what do you get?
35.
35.
35, because it's 0.5 times 70 is equal to 35. Now, what do? You add these numbers. 20 plus 24 is 44, plus 30 is 74, plus 5 is 79. So your weighted average is 79. So 79% you got overall in the class. That should put you in the C range, because grading goes like this. 90% plus is A, 80 to 90% is B, 70 to 80% is C, 60 to 70% is D, less than 60% is F. Now,
Would
here is, yes, go ahead.
for example, could that 79 potentially go up to 80 to get a B?
There was the next comment I was gonna make.
Oh,
Okay, so now you got 79%. I have seen faculty members. See if somebody got 79.8%. They got C because it's technically less than 80%, right?
It's happened to me before.
Okay, there you go. Yeah, it's a C, but I do things slightly differently. Technically, they are right. Okay, if you got C, technically you are right, but I tend to be a bit more lenient. What I would do if I see 79%, I'm gonna think, oh, student Carlos, he got 79%. Can I help him out? Okay, can I help him out? Okay, so then I'm gonna look at, hey, let's look at the participation. Can I help the student in participation? I'll try to kind of like push you in the positive direction. So he got 70% in the participation. Can I give him 80%? Okay, those are the things you need to pay attention. Those participations, that's when it will come into play. Or it doesn't have to be 79%, it could be 69%, that could be D or a C, or it could be 89%, that could be B or an A, right? So in those times, participations become significantly important. And that's one place where I leave a little room to help you out. And just so you know, I will never ever give anybody less points. Okay, John Doe is a student, I don't like him, so let's give him 0% on participation. No, I have never done that in my entire life, and I will never do it. All I do is I try to be extremely fair, and then at the end, I try to help people out who are on the borderline. Okay, 79% to me literally is almost 80%. Okay, so I'll push you up and never pull you down. That probably answers your questions, right? Yes, whoever was asking me. Yes?
yeah, it helps.
Okay. Any other question about grading? Now you know how to calculate your grade, right? You should get an approximate idea. So let's say you took the first midterm, you got an A, and you have been doing the homework, then you should pretty much be in the A range. If you got a B in the midterm, but your homeworks are A, then you should be somewhere between A and B, okay? And depends how you do on the final, that's gonna determine.
Mr. Hussein,
Yes.
explain the final.
The final exam?
Yes.
Yes,
Yeah,
final exam is gonna be comprehensive. Comprehensive. By that, what I mean is that everything that I cover starting from today until the end, okay? And until the end of the semester. And there is nothing to be worried about it. What you wanna do, you wanna keep up with the class and do all the homework and make sure that you understand the homework, then you should be very ready for the final. Even if it's comprehensive, it doesn't matter. If you did the homework, okay, and closer to the final, you look at the homeworks again and you try them out to make sure that you're okay with those, then you're fine. And typically, I tend to give a review sheet for the final. All right, I tend to give a review sheet for the final. If you go over the review problems on the review sheet or review exercise online, you should be well prepared for the final, or as a matter of fact, any midterm. For midterm, I try not to give any review problems, but for the final, I do. Okay, does that answer your question on the final?
Yeah, it does.
Okay, Alex, is there only one midterm? Did I say one midterm? I thought there were 2 midterms. Am I right or wrong in the
I think
syllabus?
the syllabus said 2.
Yeah, I think there are 2 midterms. You guys are lucky. I used to give 3 midterms before. So now I give 2. I think that's good enough. And at that time, semesters were longer. Now we have 16 weeks. And before that, we used to have 18 weeks. So during 18-week semester, I used to give 3 midterms. So you'll have 2 midterms and the final and the homework. All right, I think that's pretty much all, except one last thing, reminder, please be honest when you're taking the test. I expect 100% integrity. I'm happy to help even on the midterm or the final exam. Just ask me, okay, Tarek, I got stuck with this problem. Can you please give me a little hint? I'd be happy to do so. But on the other hand, if I find any inkling or hint of dishonesty, that would make me unhappy. Automatically, you will get an F if I see dishonesty in the class. And just so you know, I never gave an F for dishonesty, but I had to have some conversations with some students about integrity. But I was kind enough at the end. I didn't give them an F, but I gave them a grade that was more along the line of C, whereas they were supposed to get B or something like that. All right, anything else? A lot of discussion and questions about the logistics of the class. That's good. Anything else that I could answer for you guys? Okay, so will the comprehensive final have more of the materials not covered on the midterms, or will it be about evenly split between the, okay. Typically, I try to make my final exam comprehensive, meaning that I cover everything from the beginning. However, I give more emphasis on the materials that I cover at the very end, okay? There will be more questions from the materials that I have not tested you on during the midterms. Do I take attendance at the start of the class? Actually, I kind of do. Even though I didn't do it last semester, I think. If you go to this, I'm going to show it to you. Okay, before I move on to the attendance part, is that all about the midterm and the final exam? Anything else on this? Okay. Yes, anybody was saying anything? Okay. Now, if you look at the left navigation tabs, you see the student resources. Click on that. Do you see this attendance? So
we can't really see what you're looking at right now. All we see is what is it called? The homework thing, but we
No,
can't see what you're looking
I
at.
think he drew the arrow right there where it says attendance.
Oh, okay.
It's on the left side.
yeah, it is on the left-hand side right here. Under student resources, there is something called attendance. And I activate it in the middle of the class. And I tell you I give you like 2 minutes or something to go there and mark yourself present, and I do it randomly. Okay. I don't do it all the time, but I do it randomly. All right, that's all for this. Hopefully, I gave you plenty of information. And for the midterms, I will announce the dates ahead of time. I'll give you at least 1 week's notice. And if you have any travel plans or anything unusual came up, please let me know ahead of time so that I could make special arrangements for you. But please don't tell me, the exam is today. I opened it at 6 o'clock and now 7 p.m. in the evening. Oh, I couldn't do the exam. I have had some issues. Can I get a little extra time? Please don't do that. If you have something come up and you don't be able to make it, let me know ahead of time. And of course, there could be some extreme situations. So for instance, you are coming back from somewhere and you have allocated 4 hours of time and your car broke down. And now you're stuck, you're stranded. Those things are unusual things. Of course, I'll take that into consideration if that happens with verifiable documentation such as police report or doctor's note or something like that, but it rarely happens. What happens, however, from my experience of teaching many years, during the final exams, somehow the grandparents tend to die a lot. Okay, a lot of grandparents die during the final exam. I don't know why that happens. What is it?
That's sad to hear.
Yeah,
Sounds like a
a lot of
Must be like a
grandparents
way-
die during the final exams. Somehow it feels like as if
I don't think this year may be a good year for grandparents. Let's keep positive and look out for each other's grandparents this year.
In one semester, I had like 5 people saying that their grandparents passed away. I'm like, really?
Maybe they're related.
They were related. I don't know about that.
Hey,
that is all.
Quick question.
Yes.
So generally, I use the calendar from Canvas to notify me and send me notifications. Now, I know that not every professor uses Canvas, but is there a way we can get like a .cal, like reminder and stuff that we can, so that way it would make it easier for planning?
Is this Dan Orta?
Yeah, yes, it is.
Okay, Dan, you know the game, right? I sent an email. You took my class last semester, didn't you?
Absolutely. Yep.
Yeah, so I sent an email, so you know it, right?
Yeah,
I'll be sending email whenever I assign new homework. All you have to do is check your email, Hartnell Gmail regularly. Then you're on track.
Awesome. Thank you.
All right. Good. Maybe we should start talking about the materials. I have spent a lot of time. Okay. All right. So let's go ahead and start discussing the actual material. Today, I spent more than half of the class talking about the logistics, but I'll cover some topics, and then in the next class, which is a week from today, we will go heavy loaded. Okay, we'll cover a lot of materials and everything should be going much faster. Okay. First thing we are going to talk about, oh, I forgot to mention about the textbook. Somebody said something about textbook. We use OpenStax textbook. OpenStax, I think. I'll send you the, what happened? I'll send you the link for it. Or you can Google it, you'll find it. OpenStax Calculus 3, you'll find it.
So it's just a PDF.
Yeah. But another thing, I don't know if I should tell you while I'm being recorded, the best book that I have found for calculus is the Stewart's book. Okay. If you have money, please buy it. It's worth spending the money. That's one thing. However, if you Google it online, you'll find an older version for free. Stewart's textbook. I think I don't know which one is the most recent one, 7th or 8th edition.
Is it early transcendentals?
Yeah. That book is really good. Okay. But the new book might be, I don't know, 150 or something like that. Because calculus book, believe it or not, I still have my calculus book from college, and it's been 25 plus years. So keep it. It's worth buying this book. It's a great book. So if you have the money, please do so. But if you don't have the money, if you Google it, you'll find the older version online for free, and you can use that one. And it's pretty much the same thing, by the way. Okay. Next, vectors. What is a vector? You probably have seen it before, definition of a vector. Vector, the way I define vector is it's a geometrical object. A geometrical, you can also call it mathematical object too. Object that has two things. Has two things. One is a magnitude. Which you can also say length. And number two, it has a direction. So a vector is a geometrical or mathematical object that has magnitude or length and a direction. The way we kind of draw vector is this. We draw a line that represents the magnitude and an arrow at the end that shows the direction. So let's say this is U by vector. So you know what a vector is. You have seen it probably in the past. So this is nothing new. Now, the vector is typically represented in a coordinate system, and most common one is the rectangular coordinate system. So let's draw a rectangular coordinate system. That's my X and that's my Y. This is the XY plane. And let's say this is a vector. The starting point is, let's call it A comma B, and ending point where the arrowhead is, let's call it C comma D. These are 2 points. And let's call this vector U. Now the vector U, by the way, would be denoted by this. This is not parentheses, it's an angle bracket. U is gonna be C minus A comma D minus B. A vector is normally represented by this. So if you have a vector that is starting at A comma B and ending at C comma D, then the vector is represented by C minus A comma D minus B. That's what we do in the actual rectangular coordinate system. Now, by the way, this does not have to be on a plane. This is a rectangular coordinate system or Cartesian coordinate system. It's on a plane, right? It could ideally be in 3 dimensions. It could be in 3 dimensions, X, Y, and Z, right? And the concept is pretty much the same. You extend it to 3 dimensions. You extend it to 3 dimensions. That's what it is. Now, if you have a vector, let's call it V, and it has a starting point, let's call it A, comma, B, comma, C, and ending point D, comma, E, comma, F, then the vector is going to be denoted by D minus A, comma, E minus B, comma, F minus C. That's it. So in 3D or 3 dimension, the vector is denoted by this. So let's say this is the vector A, comma, B, comma, C, and that is V, D, comma, E, comma, F. Now, this is how you represent a vector algebraically, sort of in a rectangular coordinate system or Cartesian coordinate system. However, one more thing that I would like to touch on here is this. I kind of mentioned about vectors in 2 dimensions. I mentioned about vectors in 3 dimensions. Now, we could take this idea and extend it to higher dimensions, by the way. Who said that you have to stop at 3 dimensions? You could extend it to 4 dimensions, 5 dimensions, 6 dimensions, or n dimension. Technically, you can keep going. And of course, there is also infinite dimensional vector. Infinite dimensional vectors. And we don't talk about them here. In this class, we talk about finite dimensional. For the 2 dimension and 3 dimension, by the way, you can visualize it. As humans, we can visualize what a 2-dimensional vector is going to look like or what a 3-dimensional vector is going to look like. However, for higher dimensional vectors, we can't visualize it. We can't imagine it because our brain is not capable of visualizing or interpreting kind of sort of like in a real world way how 4-dimensional vector looks like. But conceptually, we can think of it that way. One example I would give you is this. For instance, this is your z-axis, this is your y-axis, and this is your x-axis, right? This is how 3-dimensional world looks like. What if you want to have 4 dimensions? So let's say if you have 4 dimensions, let's say there is another axis, let's call it W. This blue axis is going to be perpendicular to all of X, Y, and Z. In a 3-dimensional space, look, X is perpendicular to Y, X is perpendicular to Z, X is perpendicular to Y, or Y is perpendicular to X, Y is perpendicular to Z, or Z is perpendicular to X, and Z is perpendicular to Y. That means all the axes are perpendicular to each other, right? In a 3-dimensional world. In 2-dimensional world, we have 2 axes, x-axis and y-axis. They are perpendicular to each other. So therefore, in 4-dimensional world, we can think of 4 axes. By the way, axis is the plural of axis, okay? So axis is singular, and the plural is axis. EX, AX, EX, axis. So you have 4 axes, and they are all perpendicular to each other. So W should be perpendicular to Z, Y, and X. or z should be perpendicular to w, y, and x, or x should be perpendicular to y, w, and z. So they are mutually perpendicular to each other. Any pairs of x's, any two x's are perpendicular to each other. All right. That's what it is. Any question about the vector definition and n-dimensional vectors? Is everybody okay with it?
Yes.
Yes.
Okay, great. Now, another point I'd like to make, by the way, about the lectures is this class is technically a hybrid class. This is a 4-unit class, so we meet for 2 hours, and there is another 2 hours. Okay, there are another 2 hours that you are supposed to be doing home. However, what I try to do, I try to cover everything in the live session, but in reality that's not possible. So last semester I think I made 2 videos at the very end, but this semester what I'm gonna do, I'm gonna expedite things a little bit. So at the beginning or in the middle, I'm gonna make a few videos. Those are topics that you're gonna be responsible for to watching the videos at home, and I would expect you to learn the materials. Typically, I make the videos for easier topics so that you can watch the video and you'll be okay. And for harder topics, I keep them the live class. So please be prepared to receive some video lectures from me. Those are not going to be covered in the live class, but you will be held responsible for watching those videos on your own time, because technically half of the class is live and the other half is online. But I try to make it as much as I can live so that I can deliver the content to you directly as opposed to just providing videos. But still I have to give you a little bit of video. All right, so I promise I will not make it more than 5 videos, like 5 lectures, at most 5 lectures. That's it.
Will the homework cover those topics too?
Yes, it'll cover those topics. But again, even though I'll be giving you those videos to watch outside of the class time, but I would still be taking questions from those videos in the class. So let's say you watch a video, but you got stuck with something, you need help, you are welcome to ask me a question in the live class and I'll be happy to answer. Next, number 2, scalar multiplication of vectors. Scalar multiplication of vectors. From now on, I'm gonna identify a vector V this way. Vn. That means it tells you it's an n-dimensional vector. Now this n could be 1, 2, 3, 4, 5, any integer, positive integer value. Okay. So now when we say a scalar we represent it by R. You can think of it as a real number. You can think of this as a real number. So multiplication of a vector by scalar, what does that mean? So R, V with an arrow on the top, so R is a scalar. So that does mean we define multiplication of a vector by scalar is equivalent to multiplying each component of the vector by the scalar. So that is to say, r times v1, r times v2, and dot, 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 r times vn. That's what it means. So if I gave you the number 2, and you have a vector -5, 7. Okay. Now, what does it mean to multiply it by the scalar 2? What it does mean is this is going to be -10. -5 times 2 is -10, comma 2 times 7 is 14. What is the geometric interpretation of this? Here is the geometric interpretation. So let's say you have a vector v. If you multiply it by 2, what you're doing, you're taking this vector and increasing its length by a factor of 2. That means if this is 5 units long, now it's going to be 10 units long. That's what it means. So multiplying by a number greater than 1 means that you're increasing the length of the vector. Then multiplying the vector by a number between 0 and 1, between 0 and 1, what it does, it shrinks the vector. So now if this is, let's say 5 unit, you multiply it by, let's say 1/2, now is the same vector, but half the length, which will be 2.5 units long. If the blue one is 5 unit long, multiplying it by 1/2 is going to make it 2.5 units long, or multiplying it by 2 is going to double the length of the vector, or multiplying it by 3 is going to triple the length of the vector. That's what it means. Now, the next thing I want to touch on is this. So let's say you have a vector v, and you multiply it by a number, let's say r is equal to -1. What it is going to do is going to change the direction. Everything is the same, right? Length does not change. It's going to change the direction. What if you multiply it by r is equal to -5? It's going to take the same vector v and change the direction and make the length, let's say 5 times as much. That's what scalar multiplication does. It takes the vector and stretches it, or shrinks it, or reflects it. So if I could summarize it, multiplication by scalar is going to do few things. Stretch it to shrink it. 3, reflect it, or change direction, opposite direction. And yet the fourth thing, if you multiply a vector v by a 0, scalar 0, what do you get? You do get another vector that's called the 0 vector. What is kind of interesting, many times, particularly when you're learning things for the first time, you tend to think 0 times vector v is just 0. That is not technically correct. Technically correct thing is that if you multiply a vector by any number, the result is another vector. So you get the 0 vector, but this 0 vector has a magnitude of 0. And there is only one vector, which is the 0 vector, that does not have direction. 0 vector does not have direction. Remember that. So that's scalar multiplication. Any question on the scalar multiplication, anybody?
No.
You never labeled the fourth step, or does it have a name?
Not really for step 0 vector. So I'm going to just mark it here. 0 vector does not have direction. By the way, in the textbooks, you will see, let's say vector u, what they do, they use this, they use bold like u, okay? But on the screen, I cannot create bold. So what I do, I use an arrow. Some authors use the arrow on the top. So when I'm saying U with an arrow on the top, what I'm saying is I am referring to a vector U. But in the textbooks, you'll see something like this, a bold U. Okay, a bold U that is representing a vector. Just a preference and convenience. That's what it is.
Excuse me, Professor.
Yes.
So, like, I understand what you're saying, but I'm having a hard time visualizing it because I can only see when my screen is in contextual mode and not when it's in full screen.
You can only see when is your screen what?
So I have the Zoom screen on full, right? But I can't see anything. But when I reduce it to a small contextual window, then I could see it, but it's way too small. But right now,
Are you on a laptop or an iPhone or a smartphone?
Smart.
Okay, that's probably why it is. That's a technical issue. So if you're on a smartphone, it's more of a technical issue. I don't know if I have control over it, but my recommendation would be to watch it on a laptop. However, I'll just go ahead and send you the video, okay? So that you can look at.
Okay, great. Thank you, Professor.
Thank you. Next, I'm going to talk about addition and subtraction of vectors. What does it mean to add and subtract vectors? By the way, you already have seen vector multiplication of vector by a scalar. So I talked about the vector multiplication. Then now I'm talking about vector addition and subtraction. And interestingly, we do not have vector divisions. Okay, so we don't talk about dividing two vectors. So what does it mean to add two vectors? So let's say this is my vector u. Okay, this is vector u. And let's say this is my vector v. And you can move two vectors, or you can move a vector to make sure that you can align it in a certain way. That doesn't change anything about the vector's characteristics, such as its length or direction. So if you have a vector here, but you need to move it here, you can do that. Just move it here. The direction is the same, magnitude is the same. So this vector and this vector are the same vector. You just because you move it, it doesn't change the characteristics of the vector unless you change the direction or the magnitude. So if you have two vectors, u and v, to add these two vectors, what do? You take, let's say I want to add u and v. So I'll take the arrow portion or head of the vector u and align it with the tail of the vector v. And then I will create a triangle, this. And that is going to be your u plus v. All right. That's how you add two vectors. Very simple. Now, algebraically, how do you do it? Let's say you have a vector u that is, let's say 1, 2, and vector v is going to be -3, 5. So adding u with v means that you're adding the corresponding components. So 1 plus -3 is going to be -2. 2 plus 5, 2 plus 5 is going to be 7. So algebraically, adding two vectors means that you are adding the values along each component. Algebraically, this is what it means. Geometrically, adding two vectors means you are aligning the head of one vector to the tail of another vector, right? All right. And the resulting vector is going to be that triangle formed by these two vectors. So in this case, this is you. Now, what if you said, here is one property of vector. So let's say this is your v, and then that's your v, but you do, that's your u. So this is going to be v plus u. In that case, it's going to be v plus u. By the way, for a vector, u plus v is the same as v plus u. That means it does not matter in which order you add these two vectors. And this property is called commutative property. It is called commutative property. U plus v and v plus u. Now, u minus v, what do you think? Is this the same as v minus u?
Well, I have a question about that, Professor Mann.
Yeah.
So I'm looking at your diagram there, and the second diagram indicates vector v in a upward vector, and then the second vector, vector u, moves at a 45-degree angle to the right. If we're
There
making
is no
triangle,
angle. This is approximation, by the way. This is not exact approximation.
All right, so we're not considering magnitude.
We are considering magnitude, yes.
Okay, because
But
I
the
was thinking
diagram,
that.
yeah, go ahead.
Yeah, because my thoughts were a straight line in this diagram would be shorter than two angle diagrams.
Oh,
right?
don't worry about the exactness of the diagrams. I did it by hand, so they're just there to explain the concept, not to be precise. Okay, approximately, they're kind of representing the same thing. So this u and this u is the same, and this v is the same as this v.
I see. Okay, thank you for clarifying that.
Mm-hmm. All right. Any other questions? Anybody?
Can I try to assume that the triangle would still be the same, since like negative v is still gonna have the same angle, just inverted, right?
Yes. Yes.
Thanks. I just want to.
That's exactly what it is. So if you want to add u and v, so I mean subtract. Oh, by the way, do you think u minus v is going to be the same as v minus u? Is it going to be commutative? Probably no, right? No. Because you know from our base 10 number system, which you are very familiar, extremely familiar with. What are the two operations in base 10 number system that are commutative? They are addition and what? Multiplication. They are commutative. That means 2 plus 3 is 5, and 3 plus 2 is also 5. Also, 3 times 5 is 15, and 5 times 3 is 15. So multiplication and addition are commutative. Whereas division and subtraction are not commutative. That means A minus B is not the same as B minus A. Now, so let's say this is my U, and this is my V vector. I want to do subtraction. One thing you may think of is this. U minus V is the same as U plus -1 times V. Can I do that? Yes. Which, by the way, is the same as U plus -V. That means I converted subtraction into an addition. So this is a subtraction and I converted that into an addition because we know how to add. So -V is going to be, let me use a different color, is going to be reflection, right? So in this case, right? So now what I'm going to do, so this is my -V. So I'm going to add to -V, add to -V the U, right? So it's going to be nothing but U plus -V. So -V is right here. I'm going to shift it right. Let me use a different color. Shift it right here to align the head of U to the tail of -V. So then you have U here, -V here, and the resulting vector is this, and that is going to be your U minus V. And that's how you do the subtraction. So subtraction is nothing but a special case of addition. Subtraction is nothing but special case of addition.
So you always need to line the heads up to do the math.
Would you repeat that?
So you always need to line the heads up.
Yeah.
Okay.
Head and tail, head and tail. Okay.
Okay, thank you.
So, and subtraction for two vectors is easy. So let's say you have U this, V this, right? So let's find U minus V. That basically means, so I'm taking this guy and this guy. So U minus V is going to be 1 minus -3, comma 2 minus 5. So there is going to be 1 minus -3 is 4, right? Comma 2 minus 5 is -3. So that's the U minus V. So you can subtract and add two vectors geometrically as well as algebraically. Now I have shown it to you for 2 dimensions, right? But you can easily take this concept and extend it to 3 dimension or 4 dimension or in general n dimension. When your n is greater than 3, sometimes it's called hyperspace. Hyperspace. Higher dimension. Okay? Hyperdimensional, or they may use some other terms too. But the idea is the same. You can extend this idea to n-dimensional vectors. And all of you probably, I hope all of you do, will probably take linear algebra, or maybe you are already taking it this semester, right? Some of you probably are taking it this semester. This is a class you must take, linear algebra. It's very useful, particularly any kind of engineering you do. Linear algebra is fundamental, and they talk about vector spaces. Okay, the vectors you're learning here, the properties of vectors and all those things, they're going to take these ideas and extend it to higher dimensions, and you'll learn more about properties of vectors and whatnot, and how to solve system of linear equations. Because in solving many of the real world problems, you deal with system of linear equations. Any question, anybody?
No.
Okay, next we are gonna talk about magnitude of a vector, and this is what it means. Magnitude / length of a vector. When we say the word magnitude, we actually mean length of a vector. That's sort of like a math or more formal word that we use in the context of vector. So let's say you have a vector u. I'm going to show it to you very simply. Let's say 3, 4, 3, 4. That's a vector. What is the magnitude of this vector, or what is the length of this vector? Is denoted by, okay, denoted by these double vertical lines. Magnitude is square root of 3 square plus 4 square, which is 5. 3 square plus 4 square is 25, right? And square root of 25 is 5. Now you can take this idea and extend it to 3 dimension. So if you're, let's say V, a vector, you have a vector V that's in 3 dimensional. So 3, 4, 1, that is the norm of this vector is going to be, oh, sorry, I meant to say U here, not V. I changed it right there. So V is going to be equal to square root of 3 square plus 4 square plus 1 square, which is square root of 26. And square root of 26 is 5 point something. 26 to the power 0.5. Oops, we have 26 to the power 0.5. It's 5.099 approximate.
Professor?
Yes.
So just to clarify what we're looking at right here, when we're discussing magnitude / length of vector, we're looking at u, a vector u, at 0.34, and it has a magnitude of 5. Is that what we're saying?
Yes.
Okay. So say like we have a submarine, right? And it's at that point 3.4. It moves in a direction 5 and changes direction at magnitude at vector v. Right? Would that be kind of like a clear example?
Yeah, a vector, yes, you are thinking a little bit ahead. A vector could represent the position of an object, okay? Yes. So it could represent, so this 3, 4 could be representing the position of an object at this location. At that point, it could have a velocity, okay? It might be going in certain direction, right? So we will talk about it coming up. By the way, what we will do, we will trace the path of an object as it moves, and we will find its position along the trajectory or along the path, and we will find its velocity at a certain point, and we'll find its acceleration at that point. So yes, to answer your question, yes, a point could be an object's position could be represented by vectors. Does it clarify your question or no?
Yes, thank you, Professor.
Okay. Okay, different magnitudes, it can be negative. Sierra, you made a comment. Magnitude can be negative. Is that what you meant?
Oh, yeah, because when you asked whether it would be commutative to subtract the vectors.
Yeah, you can subtract two vectors, but if you do subtraction, the value along a specific axis could be negative, okay? But the magnitude of a vector cannot be negative. The smallest you can have magnitude for a vector is 0. Remember, length, the way our universe works, length cannot be negative. Its smallest value is 0. So magnitude of a vector cannot be negative. It can only be 0. However, the coordinates of a vector, the components of a vector like 3, 4, these numbers could be negative or positive or 0.
So when we would write out the answer for like a negative, like a subtraction of vectors, we would just write out the negative components.
Yeah, so let's say, let me give you an example. Let's say you have a vector W that has components -3 and -4, okay? What is the length of this one? Again, the length of this vector W is still gonna be the same, square root of -3 whole square, right? Plus -4 whole square. That's gonna give you -3 whole square is -3 times -3, which is +9. Similarly, -4 whole square is -4 times -4 is 16 positive, is square root of 25. Do you see? This vector is a reflection, I mean, of this vector, or this vector is a reflection of that vector. Even though the coordinates are negative, the length always has to come out positive.
Yeah, so the negative would like signify the direction, right?
Yeah, negative would signify the direction. It would indicate which direction the vector is. On the other hand, length would tell you how far is it from the origin.
Thank you.
Then there was another comment. Let's see. On homework and tests, should we leave it as square root or should we put it in decimal format? I think the system takes the square root at least. You can try both. I think either will be fine. And when you are answering, expressing it in the decimal format, try to round it at the hundredths place. So for instance, this number would be rounded to 5.10 because this is 9, right? So this is going to go to 10. That's going to give you 1 here. So that's how you'd enter the answer. So we talked about magnitude of a vector. Now, the last thing I kind of want to talk about properties of a vector, and then we'll call it a night. Not a vector, properties of vectors. So I'll just write it out quickly. Commutative property u plus v is equal to v plus u. Then b, associative property u plus v plus w is equal to u plus v plus w. All right. You can associate, you can add u and v and take the result, add it to w, or you could add v and w, take the result and add it to u. So associative property. This is called associative property. So the next thing is this C. There is a vector called zero vector, u plus zero vector is actually u. This is called additive identity for vector. Additive identity for vectors. And in our number system, we have additive identity, which is zero, by the way, because any number you take, add 0 to it, it gives you the same number. So 2 plus 0 is 0, 2, right? 3 plus 0 is 3, right? So 0 is the additive identity. And then we have also something called multiplicative identity, which is, let's say 2 times 1 is 2, 5 times 1 is 5. So 1 is the multiplicative identity and 0 is the additive identity for our base 10 number system. Then D, for each vector u, there is another vector negative u such that u plus negative u is going to give you the zero vector. This is called additive inverse property. Additive inverse property. And in our familiar number system, we also have it. Let's say if you have the number line 0, 1, 2, 3, and it keeps going, then -1, -2, -3, and it keeps going, right? And look, 2 plus -2 is equal to 0, right? 3 plus -3 is equal to 0. 1 plus -1 is 0. So we also have additive inverse. And similarly, we have multiplicative inverse too, except for the number 0. 0 does not have any multiplicative inverse.
I get it. So Professor, these the properties or vectors, they're a way for us to interpret more complex expressions of vectors and kind of reduce them to understandable ways, right?
Yeah, these are actually more of a vector operations. When you take multiple vectors together and you do addition, subtraction, and multiplication on them, these properties should hold true.
Got it. And then we can be able to express them in different ways. Okay, cool. Thanks.
Okay. If R and S are scalars, then you can do the following. R times S times vector U is the same as R times S times the vector U. That's called associative scalar multiplication. Associative scalar multiplication. Next property is the distributive property. R plus S, R and S are scalars, times the vector U is the same as R times the vector U plus S times the vector U. That is the distributive property. distributive property. Next, G R times U plus V. R is a scalar. U plus V is equal to R times U plus R times V. That's also distributive property. And H, norm of a vector U where did I put this property? Let me see. I'm trying to look at my notes and I don't know. Why did you put that? Okay, I didn't mean to. Well, I probably put it for identifying the magnitude. So 0 times the vector U is actually the 0 vector, which I kind of talked about it before. 0 times the vector U, the scalar number 0, okay, multiplied by U is the vector 0. This is not just 0, this is vector 0. Remember, vector 0 has no direction and magnitude of 0. And that's pretty much it for this evening. And next time we'll talk on Wednesday, a week from today. And please feel free to email me if you have any questions. I'd be happy to answer. And I have office hours now, and we'll go ahead and answer any of your questions that you may have. That's all for tonight. Thank you so very much. If you have questions, please stick around. I'll be happy to answer.
So should this cover all of the first homework assignment?